Like it's been a good school.
Yeah, yeah. It's still, I mean, it's all right.
Dad! Oh my God! You're so
Did you
cute.
see this?
Yeah.
This and this?
Oh, is that the search for fingerprints?
Yeah, it's the bridge of the Enterprise. Like I've always been using that as my background.
That's what that is.
But then, do you see that I put my logo and everything?
Yeah.
Aren't I clever?
You're so cool.
Aren't I?
You're so cute.
I know. Oh, I'm so good looking too. Oh, this is weird. I can't turn the correct way. It's counterintuitive.
I'm really proud of you, Dad.
Thank you. I'm proud of you too.
I try to recommend you to my friends
What do you think? What do you mean?
Like when they're like, oh, they're really struggling in math.
I got an email back or a text from Macintosh. I sent her the dumpster and she gave me laughings, like laughy. Oh, so true. And trust me, Dave, it's only the beginning.
Yeah.
Oh my God. It's sad but fun. Vaish, what's up?
I'm good. How are you? Are you okay? I heard what happened.
Yeah, I'm okay. It was just really a precaution. They thought it was that anyway, I won't get into it, but
Yeah.
I'm feeling better. Thank you very much for your
Yeah.
concern. Yeah. So how are you doing?
I'm okay.
Yeah.
Yep.
And we're doing some trig today.
Mm-hmm.
Is that right?
Yep. Yeah.
Okay. So I got a message from Dad about, so feel free, you can text me too, by the way, about what's going on. It's nice to
Okay,
hear
yeah,
directly
yeah.
from you too.
Yeah.
Um
Okay.
so please feel free to do that. Let's see. So it was on trig functions and inverse functions
Mm-hmm.
that you were a little concerned with. So I don't want to, I'm just going to go share my screen as with the PowerPoint real quick, just to make sure that I'm doing what you want. Okay.
Mm-hmm.
And I'll also do that so we can go back and forth. Okay. Okay. So no, I don't want that. Zoom is acting up. Okay. So do you see your PowerPoint now?
Yeah.
Okay. So I think, are you talking about identities or solving trig equations?
I think it's the functions, like graphing stuff and
Oh, graphing the functions.
like towards the end of the slides.
Okay. All right.
A little farther down, I think, yeah. Yeah, like a more up.
Up more?
Mm-hmm. I think maybe like 2 more slides, like 3 more slides. Yeah, right there, right there.
Okay. This we can do. Yes. Okay. How are you? How are you doing with your unit circle?
Good.
Good. So you feel you're on top of it. You know like what's cosine of 5 pi over 6?
5 pi over 6. Pi over 6 is a 30-degree family. 5 pi over 6 is that would be before 180 degrees. That's 150 degrees. So that the cos of that is negative root 3 by 2.
Yes, you did that so well, and you reasoned it out, and you didn't have to look at anything. So you can do that with all of them, I'm assuming.
Mm-hmm.
5 pi over 6 is one of the ones that people are like, nope, no thank you. All right, so tell me about the sine curve. Just what your general, what you know about the sine curve, the graph of it.
It looks like that, and it represents sine. That's pretty much it.
All right. All right, so here we go. Boom. Boom. And you know what? Actually, we're going to do it this way. Okay. And And I'm going to pull this on here as well. All right, so we got a big giant mess here so far. That's just sort of our reference. Can you see it okay? Can you see the values okay and whatnot
Yeah.
on the unit circle?
Yeah.
All right. All right, so the sine curve. Just like the unit circle, well, hopefully you realize the unit circle is actually on the coordinate plane, right?
Mm-hmm.
Like that.
Yeah.
And those are the points, okay?
Mhm.
So now the difference is we are going to lie the angles along the x-axis. So x is represents our angles, right?
Mm-hmm.
Okay, and then there's f of x or y. We'll just do y. Y is the sine of those angles. Okay, and this you can graph it in degrees, but it's a pain. Well, it's not a pain, but radians are used more prevalently in trig. And it's just because they're easier to deal with. The units are easier. It's pi and 2 pi, which is about out to 6 with degrees. You're going out to 360, right?
Mm-hmm.
And other reasons, but I shan't bore you with that. I said shan't. I'm sorry. Nobody should say that. So we're going to go with 0. Here's pi. Here's 3 pi over 2, and here is 2 pi. Okay. So 1, 2, 3. I'm going to say that this is 1 and this is -1. Okay.
Mm-hmm.
So it's just like, if you made a table of values, x, y, right? So when x is 0, x and then y equals sine x, right?
Mm-hmm.
When x is 0, sine is 0, right?
Yep.
And when x is pi over 2, the sine over pi of 2 is 1, right?
Mm-hmm.
When x is pi, the sine of pi is 0. 3 pi over 2, it's -1, and 2 pi, it's 0 again, right?
Mm-hmm.
So right here is pi over 2, like, boom, I don't want to mark it, it's going to get too junky, but halfway between 0 and pi over 2 is pi over 4.
Mm-hmm.
And that's square root of 2 over 2, which we really don't know that much.
Mm-hmm.
But the square root of 2 is, well, it's like 0.7 is actually what it is, okay? But as this is circular, which
Mm-hmm.
makes this curvy. Oh man, so you get this beautiful sine curve,
Mm-hmm.
okay?
Yep.
So, and that's just taking these ordered pairs. And we'll go out to -2 pi, right?
Mm-hmm.
So what? Let's see, -pi over 2, -pi, -3 pi over 2, -2 pi. And the curve goes on forever and ever and ever, right?
Mm-hmm.
So you hit to graph it, you hit what I call the main critical, I shouldn't say critical points because that takes on a different meaning later in calculus. The important points, right? The maxes, the mins, and the zeros. Okay. Okay. Notice Just like the unit circle, it is symmetric, right?
Mhm.
If you draw a line here, oops, the x-axis cuts it in half.
Mhm.
Yes.
Yep.
If I drew a line here, these are the exact same shapes, just reflected and translated.
Mhm.
Halfway between 0 and pi is the max. Halfway between pi and 2 pi is the min. The greatest value that sine can have, this goes for cosine as well, but the greatest value that sine can have is +1. The least it can have is -1. All very important things that we just sort of forget. Okay, so the x-axis for now is called the principal axis,
Mhm.
because it's the one who slices, it's the line that slices it in half horizontally. Okay, that becomes very, very important. All right, so those are the basics of the curve, and everything we learn about graphing is based on translating the sine curve. Okay, or the basic sine curve. So general form is y equals a times the sine of b times x minus c plus d. The good news is that the rule of the rules of translating functions apply to all functions, including the sine function. Okay. So nothing is really new here. It's just that we're not used to this funky kind of curve. Okay, so let's get rid of that. Get rid of that. And I'm going to move this guy over here, move him up a bit. Oops. Okay. So this is the general form, y equals a sine bx b times x minus c plus d. All right, so a, the absolute value of a is the amplitude. Have you heard this yet?
Yeah.
Can you tell me what the amplitude means or what it is?
It's the amount from the principal axis to either the highest point or the lowest point.
Good.
Or you can
What
just
is,
add the lowest point and highest point and divide it by 2. So min plus max over 2.
you know a whole lot more than I thought. What does C do?
Translation.
Okay, but which way? Or
Horizontal.
which, good. And D,
Vertical.
okay.
Translation.
And what about B?
This is like the one thing I didn't really understand. Is it like kind of like a stretch or like a, I don't really know, like a
Yeah,
compression stretch?
we really don't, that's the one thing that we don't treat the same as far as calling it a stretch or a compression, but that's excellent because the coefficient of the x term is what controls a stretch or a shrink, right? But the way we talk about the b, or the way that it's better to talk about the b, is b affects the period. Students sometimes think that it is the period of the function, but it affects the period. Do you know what the period means of this of a function or the sine function?
So like from here, I would be like from 0 to 2 pi.
Correct. And what it means, just to be clear, is that for one cycle of the sine curve, horizontally, it takes 2 pi radians for it to go through one cycle. That's what the period is, right? So we find the period or how B comes into play is that the period is equal to 2 pi divided by B. Okay. Okay. All right. So, and oh, I like this drawing. The period, usually we think of, well, they do it here, from going up to going down, back to 0, but it can be like from maximum to maximum is 1 period, or minimum to minimum is 1 period, right? Okay. So in C, horizontal translation, it gets a special name in trigonometry. It's the phase shift. It's just left or right. Okay. Your teacher does talk about vertical stretch. Well, that would be B, right? A reflection over the x-axis. We negate that. Horizontal is C, vertical is D. And are you aware of the principal axis and its relationship to D?
Won't the principal axis like move with? No, wait, no, I don't know. It want to stay the same no matter where the function goes.
I think you're correct. I think you're just saying it wrong. So let's make him red. So right now the principal axis is 0, yes? Okay, but if I move him up 1, 2, 3, if I move him up here, right? I mean, it's not drawn to scale because it's my my own, by hand drawing, right? But do you agree this is a vertical shift of 1 according to the scale in my graph?
Yeah.
And the principal axis was the x-axis, or y equals 0, right?
Oh, now it's y equals 1.
Right. And that's the vertical shift, isn't it? Because everything, the principal axis is it doesn't stretch, it doesn't compress, nothing. It's the principal axis. So whatever D is, that's the principal axis, as long as you say y equals. Right?
Yeah.
Okay. Okay, doke. All right. So 2 pi over B, absolute value of A. Yep. Okay. So then you're probably having trouble graphing these guys.
Yeah, yeah, I guess I didn't really like learn it that much.
Okay. So is there practice here with graphing?
There is only one problem.
I think there's the only one problem is the one on slide 60.
60?
Yeah.
As far as graphing a trig graph?
Yeah, I think so, yeah.
He has given one example.
Apparently there's also another example above. Maybe slide like 58.
So it's talking about the graphs of the inverse, but I don't know if I want to talk about that until you're totally comfortable with graphing a sine curve, right?
Yeah, maybe if you go up like 2 more.
It's okay. I'll find one real quick. Okay. Oh man, my eyes are watering. Okay, so let's do so we will graph y equals let's do 3 sine of 3x minus 2. Let's do that. Okay, so, and we'll do it from negative 2 pi to 2 pi.
Okay.
Okay. So, do you go ahead and sketch? Do you have pen and paper in front of you?
Yeah.
Okay, so go ahead and get an axis real quick. I like this one.
Okay, I have my axes.
Okay. There we go. That's what I was looking for. Okay. All right, that's good enough. Okay. So we're going to go from negative 2 pi to 2 pi. So the way that we do that is we compare it to the parent function of sine x. So I always recommend to just do a light sketch of your basic sine curve.
Okay.
Okay. And so you do that by hitting your zeros, your mins, and your maxes just as a guide point, right? And I always go minus the sound effects, and then I get the min correct. I don't put it at negative 2 like I did there. Okay. All right. So again, this is the basic curve. So let's list what we know. What is the amplitude?
The amplitude is like, what is it in this function?
Yeah, in this function, yeah.
Is it 3?
It is. It's the we say absolute value because if it's negative, right? But you know, we don't. It's not that big of a deal to write it. If they ask you like absolute value 3 equals 3, you can just put 3, even if it's negative 3.
Okay.
Do we have a phase shift, a horizontal shift?
No.
No, that's good. Do we have a vertical shift?
Yes, down 2.
Okay. Negative 2. And what is our period?
2 pi.
It is 2 pi over, actually, I'm going to start off, I'm going to make this a 2. Just a little bit easier for the first one, right?
Yeah.
2 pi over 2,
So it's
which
just
is pi, right? Okay, so that's what I like to start with first is the period, right? So that means this curve, this exact same shape, is going to be scrunched into just 1, right? So if I think about that, I don't have to move these points. I'm going to go in red here, right? So it's going to start at 0. It's going to end at pi, right?
Yeah.
halfway between, exactly halfway between always is going to be another 0, right?
Mhm.
And then the max is halfway between the top two, and the min is halfway between, or the first two and then the last two. And so we have an idea there, right?
Mhm.
And you don't have to do this every single time, obviously, but it's helpful, right?
Mhm.
When you first start. And then I'm going to go ahead and do it with all the way to 2 pi, because I'm asking us to graph it from negative 2 pi to 2 pi. And I'm not going to negative 2 pi yet because there's no need to. Okay. Now the amplitude is
Is 3.
3, right?
Mhm.
Now it's getting a little messy. So I'm not going to do that. I'm not going to sketch it with the 3, but I do know that the amplitude is 3 and that I'm going to shift down 2, right?
Mhm.
Okay, so this is just like, okay, I got the basics here. But then I'm going to draw my new principal axis, which is where?
-2. Y is equal to
Negative,
-2.
-2. Excellent. So I'm just going to, again, oh, I was just going to say, don't be upset about how well I can draw my principal axis as opposed to how you can. And then I just blew it, right?
Mhm.
Vice, you could have thrown me a bone and said, oh, no, no, no.
No,
Okay.
no, it looked
No,
good.
no, it's no.
No, it was good. It was good.
I was sick earlier this year. Never mind. Okay. All right. So now what we can do, our zeros aren't going to change, are they?
Mm-mm.
No. So let's do our zeros. Boom, boom, boom. I'm sorry I say boom, but that's what I do. Boom, right?
Mhm.
Okay. Now what's going to change is our maximums, right?
Yep.
Usually it's here, right? Just one up, but the amplitude is 3. So it's 1, 2, 3. Ooh, look at that. That was fortuitous. I'm not sure if that's the correct use. But the min, 1, 2, 3, right here on the watermark that I have. And then again, and then again,
Mhm.
and look how beautiful. Ah, it should be smoothie and curvy and not pointy like I just did.
No, it looks good.
Oh, stop it. Oh my God, not too bad.
I
Not too bad.
I drew this.
Let me see. Well, yeah, okay. All right, and then all you have to do is repeat that to negative 2 pi.
Mhm.
Now I'm cheating totally. Wow, how come it didn't work like that? Oh, it's because that one and I didn't get all the way up to the end. That's why. Okay, I missed some. But you get the idea, right?
Yeah.
The pattern is the same. It's a beautiful curve. I can't. It's beautiful.
Uh-huh.
Yes, so much phenomena out there. It is can be modeled using the sine curve,
Mhm.
which you've already started to learn. Is that okay?
Yep. Yeah, that was good.
All right, let's bring out the big guns. You ready?
No.
Sure you are. How come it didn't? Yeah, you know what I'll do? 'Cause I'm not as dumb as I look. Okay. All right. Okay, so now we are going to do y equals -2 sine of 2x minus pi over 2. A lot of 2's in there. Plus 1. We good?
Yep. Just
All right. So we got everything happening here, right?
Mm-hmm.
Everything's in play, A, B, C, and D.
Yeah.
Now, important to calculate, to actually do the phase shift, we need to factor out the coefficient of the x, right? So if I factor out a 2 from the x, it's just x, right? So now I'm gonna put you on the spot and say, what does pi over 2 become if I factor out 2?
Just pi.
What's 2 times pi?
2 times pi is 2 pi.
Right, I need it to be pi over 2 when I multiply by the 2. Okay, let me, here.
Wait, give me a second. Pi over 4.
You got that right, Jackson? I think the pi messes us up a little bit. We get freaked out by the pi.
Yeah.
If you think of it as 1/2, right?
Yeah.
2 times what is 1/2? It's 1/4.
Mhm.
All right. Pi over 4 plus 1. Okay, so our amplitude is
2. Absolute value of -2.
which is 2. Good. Period.
Pi. Wait, no.
Yes.
Yeah.
Oh,
yeah.
what made you think no?
Wait, do we take the first equation or the second equation?
Doesn't matter, does it? Because b is the coefficient of the x. You factor it out, it's still considered the coefficient of the x.
Oh, okay. So
right. It's never going to change.
Mm-hmm.
Unless you do something weird, like I'm going to factor out 1.75 for no reason. You know, there's no reason to do that. So it's 2 pi over 2. Is that what was tripping you up?
Yeah.
As we had factored it out? All right. It's pi. Vertical shift.
Plus 1, up 1.
Nice. Okay, here comes the biggie. You got on your big girl hoodie, so let's see if you can do it. What's the horizontal shift?
To the right, pi by 4 radians
So,
or 45 degrees. Yeah.
She knocks it out of the park. Even giving me degrees. She says it's to the right. I was sure you were going to say to the left, and we were going to have that discussion. All right, so I'm just gonna, just because I like it there. So I'm just gonna put it there. It's sort of a reminder, right, of all that is good. I don't know what that means. And then let's do our principal axis. There's lots of different ways to think about this thing. Do you have an idea in your head as to what's going to happen here?
It's gonna continue. Wait. Oh, like
just with all of this junk here. Like just a picture in your head. You can say no. It's a lot going on.
Kind of, not really.
Okay. I am going to do one more thing. This is positive sine x. What does negative sine x look like? Like y equals negative sine x. What does the negative out in front of here do?
Doesn't it just make it negative?
All right, so y equals sine x. We know, I don't know, x sine x, right?
Mm-hmm.
So what are the big, we'll just do the biggies. 0, pi
like,
over.
are you talking about like the sine of negative x is equal to negative sine of?
No. I'm talking about the graph.
Just like function y is equal to x.
So you know these, sine of 0 is 0, right?
Mm-hmm.
1, 0, -1, 0, right?
Mm-hmm.
Okay. So what about y equals negative sine x?
Oh, it would be 0, -1, 0,
Oh.
+1.
Oh. And what does that, what's going to happen on my graph?
It
The positive one becomes,
does it just flip?
yep. Anytime you have a negative entire in front of the function, boop, it flips it. Okay, it reflects, mathematically we say it reflects in the x-axis, because we say in because it's a mirror. The x-axis acts like a mirror.
Yeah.
So we should probably do that,
I guess.
just sort of remind ourselves. Okay.
Mm-hmm.
All right. Period is pi. It's going to crunch it up, isn't it?
Yep.
Okay. So we'll go with red for our actual graph. Okay, so that means don't draw these, because I'm gonna tell you how I would think about it. I might put it lightly here that the 0 is going to be here, right?
Yeah.
But we're going pi over 4 to the right, aren't we?
Mm-hmm.
Okay, so I'm thinking, all right, on my principal axis, I'm going to move my starting point for the sine curve over pi over 4 units. And pi over 4 is halfway between 0 and pi over 2, right?
Mm-hmm.
Okay. Now, then, like I know that usually pi over 2 is my max, right?
Mm-hmm.
But I have to move everything over pi over 4 units, right?
Mm-hmm.
Usually it's my max, but now it's my min, isn't it?
Mm-hmm.
And what's my amplitude? Two. So instead of, let's forget about the negative for a second. Instead of 1, it would go up 1, it would go up 2 units, right?
Mm-hmm.
But it's being flipped. So I would go from here down 1, down 2. Boom. You okay with that?
Mm-hmm.
Then we're back to a 0 again, but I got to move it over. And now it's kind of like, okay, I got it, right? I've started the cycle, right?
Mm-hmm.
And then boom, over here. Okay, so this is a cautionary thing. We're going to go ahead. So that would be for 2 pi, right? And I forgot about the period, but this is what it would look like for 2 pi,
Mm-hmm.
right?
Yeah.
But remember, the period is pi, isn't it?
Yeah.
Okay. So those points are still going to work, but I'm going to crunch it. Okay. I'm going to crunch her up. So I have to do the same thing. Like it's from here to here was a half cycle. Now it's a full cycle, isn't it?
Yeah.
Okay. So now you can start doing the symmetry game. Halfway between is a 0, isn't it? Always. And then halfway between the first 2 points, usually a max, but because of the negative, it is a min, isn't it? And then same thing over here, halfway between is usually a min, but now it's a max. We have the hardest part, which is one cycle, right? And then we just repeat it again. And if you do it by symmetry, it's so much easier. Okay. Okay, and here's caution. I didn't write it here, but if I say from -2 pi less than or equal to x less than or equal to 2 pi, and IB will do this. If you go past the domain, you get a mark off on all the graphs, any graph, right? Okay, so I kind of put the point there just as sort of as a guideline, right? But just in case I had to go past it and shoot for it. So now you just do the pattern backwards, right? You just look at your graph and they will give you graph paper and you say, oh, okay, so let's see, like 1, 2, 3, 4. So 1, 2, 3, 4. And then you can do it again, right?
Yeah.
Halfway between, and you just put your crit. I keep stopping myself. I don't want to say critical points. Your important points. And then you keep on going. Doop. Doop. Right? And then this guy is going to go back up to here, right?
Yep.
And there you go. Now I did a whole lot of talking and it seemed to take a long time, but it doesn't once, if you use this symmetry thing, like in your head, you can do that, right? Okay, let me do, I think one more that will be good for you because I've been kind of nice on the period.
Okay.
And the phase shift. Okay, so let's just do that. Let's just say we have y equals, I don't know, 4 sine of 3 times x minus 5 pi over 6. Oh my God. I don't know, plus 7. Okay. And let's do it from 0 less than or equal to x less than or equal to 2 pi. Okay. So usually the toughest thing is the period. So when it's kind of a weird period like this. So would you agree that the period is equal to 2 pi over 3?
Yes.
Okay, we're just going to worry about that for now. And I'm not even going to, all I'm going to sketch is the principal axis. Like if you sketch it freehand, or even if you, even if they give you the grid paper, sometimes the grid paper is confusing. Like when you have the shifts and the strengths and all that kind of stuff. Okay, so you might, this is a really great strategy for something sort of complicated like this. So let's just draw our, oh my gosh, let's just draw our principal axis. Okay.
Mm-hmm.
And now all I'm going to do is I'm going to sketch one cycle of the sine curve. I'm not putting any marks. I'm just putting a cycle, right?
Mm-hmm.
So as nice as I can, just one beautiful. Oh, wow. Look at that. Huh? That's a professional right there.
Mm-hmm.
Okay. The period is pi over 3 or 2 pi over 3, right?
Yep.
Okay. And what is the horizontal shift? We're going to make it plus this time.
Oh, then left by 5 pi over 6.
Left by 5 pi over 6. Okay. So this is 0. Normally the sine curve, oh my God, the sine curve starts at 0. Am I right?
Mm-hmm.
But if this moves left pi over 6, isn't this negative 5 pi over 6?
Yeah.
Right? And so that's the 0.
Mm-hmm.
Okay. And the 0 isn't the starting point isn't affected by the period because it's the starting point at 0. Okay.
Yeah.
Now over here, one full cycle, the period is 2 pi over 3, isn't it?
Mm-hmm.
Right?
Yeah.
So do you agree that if I take negative 5 pi over 6 plus 2 pi over 3, I'll get this point right here.
Mm-hmm.
So that's negative 5 pi over 6 plus 4 pi over 6,
Yeah.
which is negative pi over 6, isn't it?
Mm-hmm.
Okay, negative pi over 6. And we're still not within our domain, but hopefully you see what I'm getting at here.
Yeah.
Okay. And I'm going to give myself a little more room. Let's see. Okay, I did have it. Okay. Okay. So then what about negative pi over 6 plus another 2 pi over 3? What's happening there? I'm going to add 4 pi over 6. So it's going to end up, if I do the same curve, right?
It'll just be pi by 2.
Yay! Now I'm cheating, but who cares? That's going to be pi over 2, isn't it? Okay. Then plus another 2 pi over 3. Where is it going to go? So that's 3 pi over 6.
7 pi over 6.
7 pi over 6. So and you know what? I'm going to make this to pi instead of 2 pi. We're only going to go to pi. So this is 7 pi over 6, right?
Mm-hmm.
Well, we have between 0 and pi, don't we?
Yeah.
Okay. What is this principal axis?
Y is equal to 7.
Y equals 7. Boom. So I'm just going to mark that y equals 7, right? And so my 0 is about negative pi over 6 based on this scale. It's right here, isn't it?
Mm-hmm.
Okay. So now I'm going to put in my vertical axis. The lesson I'm giving you here is you can sketch the curve and then just label it, like draw. You can sketch the curve first if you want,
Mm-hmm.
right?
Yeah.
Okay. So I know that that is 7, don't I?
Mm-hmm.
This is 7 right here. What's the amplitude?
4.
So this is 11, isn't it?
Yeah.
So what is this?
3.
3, right? So then, you know, just like, okay, 7, 4, so maybe this is 0, right?
Mm-hmm.
And so then I can draw my horizontal axis. And then I only have to go to pi over 2 or to pi, right? 0
Mhm.
pi over 2. So, and 7 pi over 6 is too far, right? That's beyond pi.
Mm-hmm.
So, you know, using like the same, it's about here. Okay, so then you just come down pi over 2, 0. And you've got everything. So again, like you can just, okay, I got to sketch a sine curve. All right, there's one period. And then you can lay, you know what I mean? Like you don't have to move it around the graph,
Yeah, yeah.
right? And especially that's a good strategy when there's a lot going on here. Like everything is happening. The period isn't something nice. It's 2 pi over 3. So I don't know, like half of 2 pi over 3 and then a 4. I don't know. You know, it's not part of the unit circle. I mean, we do know, but it's just when you start trying to mark it up on a given grid like this, right? It just starts getting, so a quick sketch like that where you mark it yourself and you can quickly put it on the actual graph. And
Yeah.
you know, it doesn't have to be very neat for you to get your head around it.
Mm-hmm.
Is that okay?
Mm-hmm. Yeah, that makes sense.
Okay, does that help?
That helped a lot, yeah.
Okay, all right. So I think we're I know I'm so emotional about the whole thing, Vaish. It's just such a beautiful thing. You get, do your eyes like water? It's like the burning salt water thing. You're young,
Yeah.
so probably that happened to you. Us old people, like things just start happening and like, what did that happen? Why is that happening? It only happens to my dad. But now I'm the dad. So anyway. Okay, so then we will meet again Sunday.
Yeah, sounds good.
Okay, and I believe I have started automatically recording videos. I can't remember if you wanted that or not.
Oh, that would be really helpful to have. Yeah.
Okay, so then I will give you your own special Vaish folder on my YouTube channel, and I will send you the link to the folder.
Okay.
So that way I don't have to send you a link to the video every time, and you don't have to save all the all the links to the videos.
Okay.
Okay.
Yeah.
And so I mean, this is over an hour, so it takes a little while for it to
Yeah,
upload and then to process, and then that does through the checks to make sure there's nothing, whatever. So I know you want to watch this again, like immediately, because that's what I'm going to do. I don't know
Yeah.
about you. That's what I'm
Yeah.
doing.
I will.
Right. But you got to be patient, like take a break, and then you can just watch it over and over all night if you want.
Okay. Okay. Would you possibly be able to send me some practice problems with like graphing a sine curve and stuff?
Sure, I will. I didn't have a chance. Yeah, mom and dad had asked me about that. Didn't have a chance, but I will take a look.
Okay.
It's not in IB.
Mm-hmm.
There is not a lot of sketching the sine curve.
Okay.
Okay, but you have to know it, right?
Yeah.
I'm trying. I cannot think where they had a sketching of the sine curve on a paper 1 with no calculator. They do it on paper 2, but you have your calculator. And then they're looking to see if you know the max and the zeros, and like you can mark it up correctly. Okay, but you can't really do that unless you have an understanding of doing it by hand. Okay.
Yeah.
They
Yeah.
do.
Sorry.
I'm sorry.
I think most importantly, other than the sign problems, I think mostly on this chapter, on the slides, if you can send problems, that's what she is looking for. So not only the graph, other ones.
The what other kinds of problems?
For the whole chapter.
For like this unit, maybe if you have practice problems.
Okay. Okay. I will. It was on my list. I didn't get to it because I've been like boom, 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 tutoring. So that'll take me a little longer. But I will. I'll do a filter on the test bank. Yeah. For other graphs, other types of functions, they do have you sketch freehand without, on paper 1. And that's why I sort of emphasize the whole domain thing. Like if they would take mega points off of me here for going beyond, I went way beyond the domain to the left and a little bit to the right. So that would be at least 2 marks, maybe 3. Okay.
Okay.
All right.
Thank you so much. Yeah.
You're welcome. We'll see you Sunday. Okay.
Okay. Thank you.
Dave, I did send you the money for last month. Did you get it?
Yeah, I responded. I sent you an email. I will always, within 24 hours and usually right away, I send an email saying, the amount received and the date.
Yeah. So
for your records.
This is the first time, is that? Next time onwards, I don't worry. So.
Oh, okay. All right. Thank you so much.
Thank you.
Be good.